All right, so today I want to talk about something I've called mixed analysis of variance. It's got other names. Sometimes I hear people call it a between-within design, a split plot, it's called sometimes. But we're basically going to be combining between subjects and within subjects effects. So we've talked so far about simple between subjects designs and simple within subjects design. So within subject just means repeated measures. Between subjects obviously is when you have different subjects in different groups, or also sometimes called an independent groups design. We've done factorial between and within. So, well, like this. A1, A2, B1, B2. What about combining them? In fact, let's do that. I'm excited. That's why there's an exclamation point. Taught this course 23 times. Nothing excites me anymore. Except seeing your bright young faces. And I can't even see, so it's really sad. Okay, so you might ask, why am I going to do this? Is this just an academic exercise? Well, partially, I guess. But there's actually a lot of times we want more than one or more between subjects variables and a within subjects variable. Example that comes to mind immediately for me is learning for the within subjects, so performance at different times, and species. I'm a comparative psychologist. So I'm interested in how different species perform different tasks, and if that's the case, we can't do repeated measures on species. At first it was a chickadee, then we turned it into a junco. That's not a thing. And also, I can't do learning between subjects. That would be ridiculous, right? I got to look at the same subject over and over again. So, let's say you're doing species and learning, or let's say you're doing sex differences and any kind of repeated measures thing, right? So either learning would be a classic one here, or some sort of memory experiment in sex differences. There are other things that I probably could think of, but I don't feel like. So I just said etc. Or etc. rather. Okay, so that's sort of the rationale. There's actually a lot of times we're going to want to do this. Look at a repeated measure task, yet have different groups of subjects. You go to the Psychology Honors Thesis Conference, Psychology/Biology Honors Thesis Conference, you will see that there's a lot of experiments that have repeated measures and independent groups. Okay, here's an example. So we've got implicit and explicit memory tasks. Right, so implicit is filling in the blanks on word fragments. Explicit is recall of some words I've given. And then we have different attention intervals, 5 minutes, 1 hour, 24 hours. And we have one group that does the implicit and one group does the explicit. Why would you do this? There may be some concern about the explicit test contaminating results on an implicit test that you would do afterwards, possibly. Okay? Does that follow? You see why you might do that? I mean, it's actually not that big a concern, but people had that concern early on when they were doing this kind of work. So if you want to talk about different types of memory test as one variable, and then attention interval is another variable, one is between subjects, and one is within subjects. Okay? So we get a 2x3 between within.
Sorry, can you explain that one more time?
Well,
why? I don't know why that's.
Why what? What do you want me to explain?
Why is between and within?
Well, it's between subjects because some subjects, group 1, are getting the implicit test, and group 2 are getting the explicit test. It's with the within subject part is everybody's tested at 5 minutes, 1 hour, and 24 hours.
Oh, I see. Okay.
Make sense?
Yeah.
Yep. Good. So we still want a decay function. We still want to see the same people over and over again, right? Other memory decays, right? But we have two different tests. One group gets the implicit test, and one group gets the explicit test. Excuse me. Okay. So what are the sources of variation? I've said here, by the way, group 1 is subjects 1 to 10, group 2 is subjects 11 to 20. Okay. I just arbitrarily did that. I'm saying there's 10 subjects. It could have been 38, it could have been 4. It doesn't matter. I picked 10 because 10 is a nice round number. So, well, test type, implicit and explicit, that's obviously going to be one of the sources of variation. Okay? Retention interval is a source of variation. Now, what about the subjects? Because you know how with repeated measures we just assign subjects, we call subjects a variable. Well, subjects are still a variable, but you cannot now talk about subjects on their own. Okay? You have to talk about subjects in what group they're in. Right? Because then think about subjects just like any other variable. I know it's kind of a weird thing to think of, but just think of it as a variable. It's subjects within test type. That's a notation of those parentheses, and you read that as subjects nested within test type. So subjects are nested within test type. Okay? All right. So subjects are nested within test type. Good stuff.
So is that always the case with repeated measures?
No, not with repeated measures. It's the case with between subjects, so it's in fact the opposite. It's always the case with. We didn't do that before because we didn't have to. I'm building this to become a more general case for everything as we go along. So when we talk about different subjects, and so the design that's on the board there, just the 2x2,
Yeah.
in that case, actually subjects are nested within A-B interactions.
Oh.
Right? Okay. So that's how we read that. That's how you say it. Subjects nested within test type. The reason these designs are sometimes called split plot designs is because when Fisher was originally developing all these different kinds of things for analysis of variance, he was doing stuff using different plots of land. And he would have plants, look at growth rates in different plots, and he'd have the plots split, having different soil conditions. We call it a split plot. That's what it's called. So we got to build the analysis of variance summary table here. So this is an extra step down in that whole Yates order thing I was telling you about. The first thing you want to do is list your between subjects variable. So you go between, then subjects, then within. So the between subject variable, I called it test. So it's memory test type. Then I've got subjects within test. Between, subjects, within. Then retention interval. That's a really annoying noise. That's like one of those noises on Star Trek, and everybody does this, like original series. Right? They don't cover their ears like their temples. I don't understand.
That hurts their brain.
I think maybe it's because they didn't want Spock covering his ears because his ears would fall off. It's a guess, right? And then somehow Spock's okay with it because he's Spock, and somehow Kirk just logicals, like it doesn't bother him all of a sudden. And then he tells the computer, but what if I told you I'm a liar? Am I lying? And then the computer explodes. And then they recreate Paradise. Great. I love Star Trek, by the way, but I can certainly watch it and go, well, that was stupid. It's easy to do. So, between, subjects, within. And now what we want to do is go do the interactions. Retention interval by subject. Retention interval by subjects within test. We wouldn't do retention interval by retention interval. That'd be crazy, so we're done. Then we work out the degrees of freedom for each of these. So, there's two kinds of tests. Minus 1, we have 1. We have 18 degrees of freedom for subjects within test. How the hell did I get that? Well, there's, excuse me, little n minus 1 subjects per group. So 10 minus 1 is 9 times 2 kinds of tests. 18. Okay? Retention interval, well, there's 3 because there's 2 because there's Ri minus 1. There's 3 retention intervals, minus 1, 2. We get 2 here, which is retention interval minus 1 times test minus 1. That's easy. You know how to do that already. And then finally, for this, it's Ri minus 1 times n minus 1 times the number of tests. So it's 9 times 2 times 3. asking me for permission to do something at school. Different time. Back in the old days, that's it. No problem. Can't do anything. Now it's like, he texts me, then Pedro texts me in a second and say, I got the text, and everything's fine. It's crazy. Science, technology. So now what we do is we look below. If we were doing this analysis, we get the we get the mean square for test, and we divide by the mean square for subjects within test. For retention interval and retention interval by test, we test those with this error term here, retention interval by subjects within test. Okay. Okay. Questions about that? Between subjects within. That's one of those things you start saying to yourself when you go to sleep at night, and then you'll remember forever. So, between subjects within. That's the thing. And then you do the interactions of each thing as you go. And that's going to get you all the terms, and you're not going to make any mistakes. By the way, about 3/8 of the final exam marks will be doing these things. So you know what? Learn how to do it. First thing. But secondly, it's 3/8 of your points. So that's what? Is that 37.5%? Is really easy to get because you'll learn how to do these, and it becomes mechanical. And you might ask, why would you do this? Like, why would computers do all these things for us? Because people, when they analyze data, they believe everything comes out of a computer, and if they put things in and they don't really quite know how to read an output for SPSS or R or anything else, they just blindly write down what's there, and they make mistakes. And believe me, I see when I review articles for journals, the first thing I do is I draw myself to design when I read the results section, or the method section. And then I think, okay, these should be how the F-tests were done. And about 1 time in 10, someone did it wrong. And I write in my review, this wasn't done properly. Here's how it actually should be done. The mean squares were here, so I did them for you. It should be like this. It does happen. People make mistakes. So computers are great. I love computers. I have so many things. Our home network has 38 devices attached to it. I love computers. And lights, you can say, Alexa, turn on the lights. And it turns on the lights. That's the greatest thing in the world. I feel like I live in the future. You know, go to bed and go, Alexa, good night, and all the lights turn off in the house. It's so great. Computers are awesome. But also, you don't believe everything the damn computer does. Because there's so much information in those outputs. And it's there for people who are using statistics for statistics' sake. And it's there for things that are much more advanced than what we are, any of us are really interested in. So there's a lot of information in those outputs. And a lot of times people just don't know how to read them, and they just blindly write things down. Okay? So there's a reason to learn this stuff. It's not just busy work. The first thing you should do when you read an article is draw out the damn design and figure out, I'm serious, by the way, and figure out how they should have done their statistical tests, because also things go through cracks. Things get through that are done wrong. You figure out the error terms? Pretty straightforward. Now this assumes everything is fixed and subjects are random. And that's a good guess. That's a good guess. Okay, let's do another example. N is going to equal 5 here. Like where that came in? I kind of like it. So we've got ABC. So this is well, what are the between subjects factors here, if any? Because we're going to go between subjects within. First thing you want to do is just say what the between subject factors are.
So is between the A1 and the A2?
Yeah, A is a between subject factor, yes. And why is that, Heather?
Because They're two separate groups, so you're comparing different people.
So you've got different subjects get different levels of A. Are there any other between subject factors? What does it look like? Do you see any other between subject factors? No. Because every subject gets every level of B. Everybody gets B1, everybody gets B2, and everybody gets B3. Everybody gets C1 and C2. So this is a 1 between, 2 within, 2 by 3. Put that over there. Between subjects within. Between is A, within are B and C. Just like we figured out. So what we're going to do is when we make up this analysis variance summary table is we're going to get the between subject factor listed first, and that's going to be A. And then subjects are going to be nested within A. Because think what that means. They're within different levels of A. That's all that means. And then B and C. And there are 5 subjects per group. That's what N equals. So, here it is. A, S within A, just like I said. Whenever I do these things, I do the degrees of freedom later. I worry about that later. I can calculate that. That's just doing some arithmetic. The harder part is this. Right? Okay. Well, let's do C next. I don't know. Maybe you would have chosen B. It wouldn't make a difference. They're both within. C. C by A. C by S within A. You can't do C by C, so you stop. B. B by A. B by S within A. B by C. B by C by A. B by C by S within A. Done. Now you do the degrees. Now, this is what I do. If you want to do the way you like to do it is you do the degrees of freedom as go. That's great. I just find that I can get on a kind of a roll of doing it properly by just doing the source of variation first, then the DF. But whatever works for you. Oh, A minus 1. There's 2 levels of A. 2 minus 1 is 1. N minus 1, so that's 4 times 2 is 8. Great. C has 1 degree of freedom, C minus 1, A minus 1, and etc. When you add them all up, do they add up to, well, there are 60 observations. There are 59 total degrees of freedom. Does it add up to 59? Yeah, it does. And chances are, if you did this incorrectly, they're not going to add up to 59. So it's a pretty good double check of your work kind of thing. You go along and say, does that add up to 15? Yes, it does. I probably did this correctly. What are we going to test with what? We're going to test A with S within A. We're just going to go below it, the thing that has it and subjects. C, C by S within A. C by A, C by S within A, etc. Yeah.
Okay, so for C, you know, C minus 1 equals 1, but weren't there 3 levels of C?
Does C have 3 or C have 2?
I don't know.
C is 2.
C has 2, I think B has 3. Yeah.
Oh.
Yeah. And the thing is, the hardest part people always have, I think, is doing the terms with the nesting in. And there's a little sort of mnemonic you can use that I've always used, which is all the things that don't have brackets when you're doing the degrees of freedom calculations have brackets, and the thing with brackets has no brackets. That's just works for me. It doesn't work for you, that's fine. But it's just a little sort of mnemonic I figured out years ago when I first did this in 1988. Something like that. Sometime in the 80s. Sometime pre-grunge. Kurt Cobain was like a young teenager the first time I did this. Not probably an older teenager. Yeah. I think the Pixies were already around. Anyway, I think the Pixies are way better than Nirvana. Fight me. I think it's true. Just saying. Maybe people care. I never thought talking about different bands would make me feel so old, but it just did that. So, let's do another one. Why not? I got more. That one just appeared strangely as well. Sometimes I like those effects. They're fun. They're stupid. I don't feel like an idiot. So, 1, 2, 3, 4. Oh, this is interesting. Do we have any? Well, we must have some between subjects factors because it's not all the same subjects. Look at your face, is priceless right now. There's a picture. I can take a picture of that. I can use that as the cover page for the study group. No, it was great. It was like,
I'd go to the study group if I saw that. I'd be like, that girl, she knows what I'm thinking.
no, I get when you look at this, I'm serious. I'm sorry if I embarrassed you.
No, that's okay.
I'm not really that sorry. But I did. You guys are great. No, but seriously, I get why you have that look on your face because this is a strange looking design. Let's try to break this down into something maybe, we can make it into an example. But let's first, before we do that, we can actually make it somewhat concrete. But let's first, what are the between subjects factors? This is why this does get confusing because it's like, okay, what's between and what's within? So which variables the different subjects get different levels of? That's what you're asking, Sean.
A1 and A2, B1, B2?
Yeah, so A and B are clearly, and this is where it gets confusing, right? Because you look and go, what? Okay. Right. So different levels of A and different levels of B. This is correct.
Can you explain to me why C isn't?
Because every subject gets every level of C.
There's 2 columns for each C though.
Everybody's getting C1, everybody's getting C2, and everybody's getting C3. You see that?
Oh, yeah.
Yeah, so that's repeated, it's within. And now it suddenly makes a little bit of sense. I kind of saw some dim light bulbs, but light bulbs nonetheless. So let's think of something. We would have 2, I don't know, how about, yeah, that's good. So let's say A is different kinds of memory tests. A1 is recognition, A2 is recall. Okay? And what could B be? How about men and women? Sure. B1 is men, B2 is women. Okay? So this is recognition, recall, men, women. C is 5 minutes, 1 hour, 24 hours. Right? Now, actually, that doesn't sound like the idea that men and women differ on recall would be kind of silly, but it could be any set group. I just picked sex, why not? But we got men, women, we've got recognition, recall, time 1, time 2, time 3. That's all that is. Now it's like, oh yeah, I can see how someone could do that experiment. It's not exceedingly complicated. We're just testing the same people 3 times, and they're divided into, they have different levels of A, which is I think A was the memory test type, and B was the sex. Right? So it's not like it's a crazy design. It looks crazy with just A's, B's, and C's. I get that. The thing is, it's actually easier to write A's, B's, and C's than it is to write down different names of variables because it gets really complicated when you're working with basic freedom. That's why I did A, B, and C. Okay. So put that one over there. So A and B are between subject factors. Subjects are nested within A-B interactions. Subjects are nested within A-B interactions this time. Not just A or not just B, but A-B. Does that make sense? Well, how does that not make sense? Could you talk about subjects by just talking about levels of A? No. Can you talk about them just by talking about levels of B? Yeah, now it makes sense, see? So then you go, oh, I see, it's the combinations of A and B. Yes, Chris?
Is this in the test?
This one's covered? No. The test is everything up to before we did repeated. Not the repeated stuff.
Oh.
Ooh. Yeah. With the relief in the room, I actually, the temperature actually went down with 3 degrees. Suddenly it smells less like fear sweat here. That's good. It'll be on the final, all this. Like I said, this stuff's all on the final. But no, that test, I should actually restructure the way the order I do the topics, or the time I say I'm going to spend on them, because we didn't spend as much time on certain things I thought. And that's been pretty consistent, so. So the last topic on the test is factorial analysis. Okay? So don't get too worried. Now the relief is unreal here. It's great. I've never seen a brighter smile on sales since my life. It's really impressive. I can do that all the time. No, that's not on the test. Make you feel like a hero. Okay, so far, so subject and answer did A-B interactions. And I just said 6 per group because why not? So that should tell us, let's see, we have 12 cells, right? So 12 times 6, there should be 72 observations. There are 72 observations. So 71 total degrees of freedom. Keep that in your head. So when you work out the degrees of freedom, does it actually work out that way? Right.
Sorry, can you do that?
Do what? I go back.
You
Yeah.
just said to keep that in your head with degrees. I missed what you said to get to the degrees.
Whoops. What am I doing?
But they weren't.
That's the example there, right? No, that's the one before. What am I doing? And then that happened, and then everybody, there was much rejoicing, and then this happened, and then Chris said, is it on the test? And then I said no, and then there was way much rejoicing. Okay, so there are 6 observations. I just said there were 6. Again, this is just arbitrary. Anything on a test, on the final exam, this is not on the upcoming test on Thursday. Again. I would always tell you how many subjects there were per group, because you can't do it without that information.
Oh, so the number of observations
Is 72. Because there's 12 cells and there's 6 subjects per group. So 12 times 6 is 72.
I knew that. My
72 minus 1, plus 72 minus 1 is 71. So 71 total degrees of freedom. No, it's okay. Don't apologize. I appreciate the questions. It's if you have them, ask them. If you don't, you'll get lost. And I don't want anybody to get lost. Okay. So, this one's a little weird. Also, the slide has no title, which is odd on its own. But, A by B. There, we do the betweens first. We don't talk about subjects yet because we haven't got there. A, B. Now talk about subjects because we have no more between subjects. S within AB. C by A. C by B. C by A by B. C by S within AB. And as Gordon Ramsay says, whenever he finishes a recipe, it's on this one.
For S by A by B, you said N is 6, so N minus 1, 5, A, B are both 1, what's that 20?
A, B are both 2.
A, B are both 2?
There are 2 levels of A and 2 levels of B.
Alright.
Yeah, and like I said, that's where you make a mistake. That's where I have always made mistakes. When I learned to do this stuff a long time ago, that's where I would make a mistake. So A by B. C, CA, CB, CB. Sounds like big brown bear. It's funny how you all know what I'm referencing there. That's great. And one day you will have children, and you will have that little thing with Dr. Zeus books.
I may be living that right now.
Because everybody has that. You have the one with
In French.
Oh, okay, sure.
No,
Is it
no,
the cat in the hat?
I'm baby shark right now.
Is it the cat in the hat holder? It's red. Okay. And eventually you find out that you hate reading those books to your kids. You hate it so much. And you start doing things like, I would read Green Eggs and Ham to my daughter, but I would do it in different characters because it was driving me crazy. So it'd be like William Shatner talking to Bill Clinton because it was the early 90s, right? So,
Mine just figured out that I skipped pages.
oh yeah.
And now I can't see pages anymore.
I would not eat them in a boat. I would not eat them in a boat. And then I go, Todd, you made what? Dad, stop it! But I hate this book. It's driving me insane. Yeah, or I'd do like, usually it was a politician or an actor. You know, something I could do pretty easily. So I'd tell you a story or something like that. A lot of fun. All right. So, any other questions on this before we stop the recording? We can talk about other stuff. And we can even do another one of these if you want.
Can we?
Yeah, it doesn't make for compelling watching.
Can I do it now?
Yep.